Okay, we're going to have a quick run through with that's part of MT3. So the first question is a Poisson distribution, and we did this in the labs. So we just calculate probability distributions. Poisson, we put in a mean of 0.5, so that's what's there. And what's the probability that exactly 1? So we've got to pick probability, and we put in a constant of 1, so that's our exactly 1 distribution. So we can pick that up and just pop that in. I'll move that in a minute. And the next part of the question is at least 2 missing. So if we go to our thing here, we've got at least, so at least, oh, it's greater than. So we're going to have to do a complement to move that around. So what we'll have to do is come back here and we do a complement, which means we've also got to do calc probability distributions plus 1. We're going to do a cumulative. Now that will leave it at 1 because we're going to do the complement. So we'll go OK, and we'll use our calculator, and we'll go 1 minus 0.909796, and that uses 0.09204. So we'll just pick that up and pop that in, and we want to check this answer, so we'll go away and see if they're correct. And when we come back, we can see that we've got full marks for both of those. Okay, so that's fairly straightforward. For this guy here, it's an exponential, but 1 over 1 is 1, so that's the trick there. So 1 over 1 is 1, so we've got a cumulative distribution of 4, so that should be fairly straightforward for us to go to probability distributions, exponential. We're doing a cumulative, we're doing 1 over 1, which is 1, so that's fine, and we're doing an input constant of 4. Okay, so we just pick that one up directly and pop it in and go and have a look and see how we went. So if we hit that again, we can see that that's great. Alright, now this one here might be a little bit different. To note the distance that an animal moves from its birth site to the first territorial vacancy it encounters, suppose that for bent-tailed kangaroo rats x has been exponential with a parameter lambda of 0.01427, what's the probability that the distance is at most? So at most is the language, so if we just check our little chart again, at most is cumulative, so we do the cumulative probability at most 100, but this is a problem here because we have to do 1 over lambda for the exponential. So 1 divided by 0.01427 is 70.077. That'll round to 70.1. So I'll use 70.1, and we're going for 100. So 70.1 on an exponential. So we'll go calc exponential. The average is 70.1, and we're looking for 100, aren't we? Okay, and just checking that is at most 100, so that's correct. So we put in the correct average based on the 1 over lambda, it's cumulative, and away we go. Alright, so we just grab that, pop that in, and go down and check that. How do we go with that one? And he didn't like it. Pause. And if I put in that rounded 0.760 and try that one, that's 7.59, 7.60, it accepted it. So there you go. Alright, thanks very much.